Hello and welcome back. As I promised last time, today I will tell you more about hydraulic fracturing. Actually, there are several types of hydraulic fracturing. There is conventional fracturing, when we inject fluid at high pressure to create fractures and then pump in propping engine to keep these fractures open after the pressure is removed. Then there is TSO, tip screen out technology. This is a modification of conventional fracturing. Then we create fractures that are extra wide, up to 40 mm. This is commonly done on high productivity wells to decrease flow turbulence and control sand production. And the third one is acid fracturing, when we use acid as a technical fluid. Injection pressure is enough to create fractures, and the acid washes these fractures out, so that even then the pressure is removed, deep, high conductive channels remain in place. The major purpose of any frac operation are the following: to improve potential of new wells by trying to drop the skin factor below zero, to fight production decline caused by asphaltens, paraffins, salts, and other precipitation contaminated the formation, to find sand production from loose formation, to restore well productivity after workover operations, to improve recovery factor, which is especially important when we deal with low permeable reservoirs or tap previously not drained reserves. Hydraulic fracturing helps us to increase effective well drainage ratios and create conductive channels that cut through the damaged near wellbore area. Thus, the most important characteristic of a fracture created during a frac job are its length, width, height, and spatial orientation. All this should be planned during the fracturing design stage. To do so, we need to account for multiple geological and technical factors. Geological factors that control fracture parameters are formation lithology, reservoir properties, spatial arrangement, fluid contacts, natural rock stress distribution, mechanical rock properties, reservoir pressure and temperature. As for technical factors that might influence fracture parameters, these include wellbore trajectory, casing and cement integrity, reservoir completion quality. This information can be obtained from various well logging data, and we already know what well logging is. I should mention that for frac design purposes, we need logs not only from productive intervals, but from the adjusted formations as well. Let us prepare for a frac job. The fracture will propagate in the direction perpendicular to the minimum rock stress, starting at the perforation channel and then going round the wellbore until it starts propagating. Sometimes the created fracture is not wide enough, so we will not be able to pump in the whole volume of proppant and the operation will be aborted. To do a better job, it is recommended to perform a test before a main frac job. Instead of several hundred or even thousand cubic meters of technical fluid, which in this case is called fracturing fluid, we try and pump in less than 5 cubic meters. This is called microfrac, or less than 50 cubic meters. This is called mini-frac. From these tests, we obtain valuable information such as rock fracturing pressure, fracture propagation, and fracture closure pressure, as well as minimum stress in the wellbore area. After a mini-frac or microfrac, we are ready for the main operation. Let us review frac job stages. First, we gather data and design the frac. Then, we inject fracturing fluid at a pressure above formation fracture pressure. This fluid should be strong enough to create a fracture. It should not invade the formation, and wellhead pressure should be relatively low. And all can be achieved using a viscous oil-based or water-based gel that will degrade afterwards. Then we fill the created fracture with propping material so that it would not close down. Finally, we remove the pressure and wait for the fracturing fluid to degrade. Please pay attention to the schematic that shows fracturing equipment arrangement on a well site. Blender is a truck-mounted device that mixes technical fluid with proppant and chemicals and then sends this mixture to the pumping station. It is the most important component of a fracturing system, which should provide a good quality blend of fluids, propping agent, and chemicals. It has a quality control station which monitors the process. Pumping station is also mounted on a truck. It pumps fracturing fluid and prop it into the well. Ready fracturing fluid goes from blender to the pumping station through a pressure manifold. It has two separate pressure systems so that they would not interfere with one another. Sand trucks, as you can imagine, are trucks that bring sand. Actually, they do not only bring it, but also load it into the blender in strictly measured volumes. Frac control station is a computerized center that controls the pumping stations and gathers all the information about the operation in real time. Reservoirs for technical fluid are usually thermos-like, insulated containers that keep the fluid warm. Thanks to that, frac operation can be performed in winter time as well. These major components can be complemented by additional burners and other installations such as heating and cleaning devices. For better understanding of all hydraulic fracturing operation, let us turn to another schematic that shows detailed arrangement of fracturing equipment in plan view. Fracturing fluid, which is oil or water-based, is kept in special reservoir connected with a pipeline system. Low-pressure pumps pump technical fluid into blender 1, there it is blended with polymer concentrate until a uniform polymer solution is created. The resulting gel goes to blender 2, there extra chemical agents are added, such as cross-linkers, spacers, thinning agents, etc. Quality control is performed here as we need to make sure that the technical fluid conforms with our requirements. Propellant is also added at blender 2, brought by a conveyor belt. Density control is performed to make sure that the right amount of propellant is being added. After blender 2, technical fluid goes to high-pressure pumps which should provide enough power for ejection at the design pressure. A double pipeline is usually used to reduce pressure loss. Control station monitors process characteristics such as bottom hole and wellhead pressure, injection rate, fluid properties. It is all done in real time. Backup pumps, blenders, and transporters should be in operated conditions and connected to the whole system before the operation starts. Thus, we can avoid a lot of trouble if anything's going wrong with primary equipment. We also have to make sure that there is enough fluid for the whole operation. Fracturing fluid is forced into the formation by the displacement fluid. After that, injection stops and the well is shut down for the period enough for fractures to close and fracturing fluid to degrade. Then we can complete the well and put it back to production. Now you know almost everything about hydraulic fracturing. Only a bit more is left to learn. In our next video, we will talk about acid treatment. And this is it. See you!